Good morning. First year BSc statistics class. So today we discuss about measures of variations. Today we start with, we already begin in the last class. So we start with measures of variations. So what are the different types of measures and techniques to find out the variance of data? So first one is range. What is range? The range of data set is the difference between the maximum and minimum data entered in the set. So range is equals to maximum data entry minus minimum data entry. That is, the following data are closing prices for a certain stock on 10 successive Fridays. Find the range. So here we are giving 3 plus 3 plus 3, 10 values. We want to find out the range. The range is maximum value of the data minus minimum value of the data, that is 67 minus 56, that is 611. Deviation. Deviation means, what is the meaning of deviation? Deviation means the distance between the data item from center point, or median value or mode value. So the deviation of an entry x in a population data set is the difference between the entry and the mean mu of the data set. So what is the deviation? Deviation is nothing but it is the difference between the data item from the mean of the data. Means the deviation is nothing but it is the difference between the data item and the mean of the data item. So deviation of x is equals to capital X minus mu, where capital X is equals to data item and mu is the mean of the data item. So the following data are the closing prices of a certain stock on 5 successive Fridays. Find the deviation of each price. So the mean stock is equals to, so stock x, sigma x is equals to 305, and mean mu is equals to 305 by 5, that is equal to 61. So deviation is equals to, generally deviation is measured for each and every data item to be taken. So deviation is equals to x minus mu. X is individual data item, that is 56 minus 61, 58 minus 61, like that. So sigma of means sum of all the x minus mu or x minus mean is equals to 0. So sigma of x minus mu is equals to 0, where mu is the mean of the data item. Next, variance and standard deviation. So there are different terms here we discussed: range, deviation, variance and standard deviation. So what is variance? Variance means the population variance. What is the population? Population means generally the data item taken. So the population variance of a particular data set of n entries is, population variance is equals to sigma square. Sigma square is equals to, so generally variance is represented by sigma square. Sigma square is equals to sigma x minus mu whole square by capital N, where capital N is the number of entries, number of data items, where capital N is the number of data items. Sigma x minus mu whole square. X minus mu means, sigma x minus mu whole square means the difference, the square of the sum of the square of the. What is the meaning of deviation formula? Deviation is equals to, variance is equals to, that is sigma square is equals to sigma x minus mu whole square by capital N, means the sum of the squares of the difference between the data item and the mean divided by number of data items is called as the variance. So sigma square is equal to sigma x minus mu whole square by capital N. The population standard deviation of a population of a data set of capital N entries is the square root of the population of variance. So what is the standard deviation, or SD? What is the standard deviation, or SD, is equals to mu. Standard deviation is represented by mu. Mu is equals to square root of mu square, that is square root of sigma x minus mu whole square by capital N. So deviation is represented, standard deviation is represented by sigma, and variance is represented by sigma square. So variance is equals to sigma square, that is equal to sigma x minus mu whole square by capital N. Standard deviation is equals to sigma, that is square root of variance, that is square root of sigma x minus mu whole square by capital N. So finding the population standard deviation. So how to find out standard deviation? Step by step methods. So how to find out standard deviation of a given table or a given data? So first one is find the mean of the population data set. That is, what is the mean? Mean is equals to sigma x by capital N, where x is equals to data item, single data item, and capital N is the total number of items. Capital N is the total number of items. Second one is find the deviation of each entry. Means deviation means what is the deviation? The distance or difference between the distance from the point to the mean of the data. What is the deviation? Deviation is nothing but the distance between the data item from the median, or from the median or mean of the data set. Third one is square each deviation. Means next step is, in the next step we have to find out square value, that is x minus mu whole square. Fourth one is add to get the sum of squares. So next is to find out the sum, or to add all these values, that is sigma x minus mu whole square. So add to get the sum of squares, SS. What is SSX? Means sum of squares. SSX is equals to sigma x minus mu whole square. Next one is divide SSX by capital N to get the population variance. Means what is variance? Variance is equals to sigma square. Sigma square is equals to sigma x minus mu whole square by capital N. Next is find the square root of the variance to get the population standard deviation. Find the square root of the variance to get the population standard deviation. That is, what is standard deviation? Standard deviation is equal to square root of variance, that is square root of sigma square, that is sigma is equals to square root of sigma x minus mu whole square by capital N, total whole root. So this is the step by step method to find out the standard deviation. Population standard deviation and standard deviation both are same. So next is finding the sample standard deviation. So population standard deviation and sample standard deviation. Sample standard deviation means here we have to find out the standard deviation for a sample value, for a given value. In this example, in the previous slide, we may find out the population of standard deviation of entire data set to be taken, whereas Sample standard deviation means we may find out the standard deviation for a given value. For a given value means, what is sample standard deviation means, here we are going to find out standard deviation for a sample value, sample data set. So the step 1 is find the mean of the sample data set, that is x bar is equals to sigma x by n, that is common. Second one is find the deviation of each entry, that is here in the population standard deviation, that is x minus mu, that is x minus mean, whereas here we find out x minus x bar only, x minus x bar only, x bar only means there is no. So what is the difference between population standard deviation and sample standard deviation means, in the population standard deviation we may find out the taking differences between x and mu, that is mean. We are taking or finding the standard deviation from the difference from the to be taken as the difference between x and mu, that is mean. Whereas in the sample standard deviation we are taking x minus x bar. What is x? X is the sample data set, minus x bar is the mean. X bar is the mean. X bar is equals to sigma x by capital N. So here we simply find out the difference between the mean of the value, mean of the data set from the with the data item taken, So what is the difference? X bar, x minus x bar, x minus x bar. What is the difference between what is the difference? X minus x bar. So here we are taking x minus x bar, where x bar is the mean of the data set, that is x bar is equals to sigma x by n. So find the deviation. So in the population standard deviation we may take mean for calculating the deviations, whereas in the sample deviation we may take mean. In the previous value we may take that mean of population, whereas in this sample standard deviation we may take it ordinary mean. So find the deviation of each entry, that is x minus x bar, square each deviation, that is x minus x bar whole square. First step is add to get the sum of the squares. So sum of the squares, SSX, sum of the squares, SSX is equals to sigma x minus x bar whole square. Next one is divide by n minus 1, divide it by n minus 1 to get the sample variance. So in the previous example, in the previous population standard deviation we are taking capital N, but in this so for sample standard deviation we may take small n minus 1. Small n is the number of data items. So s square is equals to, so divide the sum of the squares by n minus 1 to get the sample variation. So s square is equals to sigma x minus x bar whole square by n minus 1, where n is the number of items. Next, in the sixth step, find the square root of the variance to get the sample standard deviation. So what is the sample standard deviation? What is the sample standard deviation smallest is equals to, what is the sample standard deviation smallest is equal to square root of s square, that is square root of sigma x minus x bar whole square by n minus 1. Sigma, so what is the sample standard deviation? The formula for finding sample standard deviation is equals to, s is equals to square root of sigma x minus x bar whole square by n minus 1, where n is the number of data items. So in the next slide we are going to find out how to find the population standard deviation. So taking some examples. So in the previous slides we are using two formulas to find out population standard deviation and sample standard deviation. So we are taking, in this slide we are taking some examples for data sets or data for finding population standard deviations. So how to find population standard deviation? How to find population standard deviation? So the following data are the closing prices for a certain stock on 5 successive Fridays. The population mean is 61. So mean is 61. Find the population standard deviation. So we are giving stock X, that is 56, 58, 61, 63, 61, 67, and sigma x is equals to 305. Deviation mean is, the population mean is 61. So sigma x is equals to 305 by n means 5, that is 61. So that population mean is 61. Next is deviation. What is the deviation? Deviation is the difference between the distance between or a difference between the data item with mean. So next we calculate x minus mu. X minus mu, that is mu is the mean. So 56 minus 61 is minus 5, 58 minus 3, 61 is minus 3, 67 minus 61 is 6. So x minus mu. So sigma x minus mu is equals to 0. Sigma x minus mu is equals to 0, and squared x minus mu whole square. Next is x minus mu whole square is 25, 9, 0, 4, 36. So x minus mu whole square is 25, 9, 0, 4, 36. So sigma x minus mu whole square is equals to 74. Sigma x minus mu whole square is equals to 74. So what is the formula? SS2. SS2 means sum of the squares. SS2 means sum of the squares is equals to sigma x minus mu whole square, that is 74. Next is, what is the formula to find out the standard deviation? That is variance. Sigma square is equals to sigma x minus mu whole square by capital N, that is 74 by capital N means number of data items taken, that is 5. So that is 14.8. Next is variation. Variation is equals to mu is equals to square root of standard deviation. Variation mu is equals to square root of standard deviation, that is square root of sigma x minus mu whole square by capital N, or square root of sigma square, that is square root of 14.8, that is 3.85. 3.85. So population standard deviation is equals to approximately 3.85. So next is interpreting standard deviations. So how to interpret or how to represent graphically the values of standard deviations. So when interpreting standard deviation, remember that is a measure of the typical amount an entry deviates from the mean. So the more the entries are spread out, the greater the standard deviation. So while you are representing or while representing graphical representation using standard deviation by using some bar charts, so here we may observe that how much the data item is deviated from the mean. We have to calculate or we have to observe that how much the value of the data item, how much the data item is deviated or differentiated from standard deviation. So the x-axis we may take as some data values, that is 0, 2, 4, 6, and y-axis also we may take some values, frequencies. In the y-axis we may take some frequencies, that is 0, 2, 3 up to 14. So this bar graph represents x bar. Here x bar is equals to 4, and S is equals to 1.18. So, next concept is empirical rule. What is empirical rule and how to represent it with some graphical representation? So, empirical rule for data with a symmetric bell-shaped distribution, the standard deviation has the following characteristics. About 68% of the data lie within one standard deviation of the mean. About 95% of the data lie within two standard deviations of the mean. About 99.7% of the data lie within three standard deviation of the mean. So, this is the chart or so we may continue with the next class.